another Harvard question. We have solve 25 raised to the power x minus 5 raised to the power x minus 20 is equal to 0. Permit me to divide the board into 2 and begin by saying solution. Repeating the question, we have 25 raised to the power x minus 5 raised to the power x minus 20 is equal to 0. Permit me to say that 25 is equal to 5 raised to the power 2. If this is true, then I can substitute my 25 for 5 raised to the power 2, and as such I'll be having 5 raised to the power 2 or raised to the power x, because of this raised to the power x minus 5 raised to the power x minus 20 is equal to 0. Now looking at this, we have 2 times x to be 2x, 2 times x to be 2x. Also, I can say x times 2, it will also give us 2x. So if this is true, then I'm going to substitute this, I'm going to replace this x for the 2 and 2 for the x. So I'll be having 5 raised to the power x all raised to the power 2 minus 5 raised to the power x minus 20 is equal to 0. So 2 times s is 2x, x times 2 is 2x. The reason why I did this is simple. I want 5 raised to the power x to be called p. As such, I would say let 5 raised to the power x be equal to p. If this is accepted, then I would say 5 raised to the power s is p squared minus 5 raised to the power s, of course, is p, so minus 20 is equal to 0. So this is now a quadratic equation. So let's solve using trial error method. Of course, if we're using trial error method, we're going to find the pairs of p squared and the pairs of minus 20. So we're going to consider the pairs of p squared and the pairs of minus 20. How are we going to do this? Having p squared and minus 20, our target is to find, with the pairs of p squared and minus 20, the coefficient of this p, which is minus 1. So if I have p here and p here, of course these are the factors of this p, and finding the factors of 20, let's say we have 10 and 2. Let's use scissors method. And of course this is minus 20, 10 times 2 is 20, let's put minus, this is another pair. Let's find another pair again. Let's say we have again 5 and 4. 5 times 4 will give us 20, of course that's minus here. So why are we using this scissors method? We want to find what will give us the coefficient of this p, which is minus 1. So if we say minus 10 plus 2, because ordinary 2 is plus 2, so minus 10 plus 2 will not give us minus 1, the coefficient of this p. So this is cancelled. Coming here, minus 5 plus 4 will give us minus 1. So minus 5 plus 4 will give us minus 1. So it means that if we factorize this, what we'll be getting is p minus 5 and p plus 4. So if that is true, permit me to wipe here. Sorry, we have p. So if that is true, it means that p squared minus p minus 20 is equal to p minus 5. So when we factorize it, we get p minus 5 and p plus 4. So we get p plus 4 is equal to 0. If that is true, if p minus 5 and p plus 4, of course, in our respective factors is equal to 0, it means that p minus 5 is equal to 0 for this, and p plus 4 is equal to 0. So if this is true, if 5 crosses the equal sign, our p will be equal to plus 5, and if plus 4 crosses over here, our p will be equal to minus 4. So this is considered invalid because of the minus sign. It's considered invalid. So we are not taking this answer, and this is the correct answer for p because it is positive. And if this is true, recall that while we were solving, we stated that 5 raised to the power x is equal to p. And as such, if that is true and our p is 5, so we say if 5 raised to the power x is equal to our p is 5. So we have 5. Note that 5 is same thing as 5 raised to the power 1. So if I say 5 raised to the power 1, it still depicts 5. So if I cancel 5 and cancel 5, x may be equal to 1. And this is the answer for this question. Please, if you have any challenge or if you love the way we solved this math, I want you to put it down in the comment section. Thank you.